Hello, everyone. So thanks for joining us today. My name is Murat Karslioglu. I'm the VP of Product and Solution Engineering at MayaData. Today, I have Sergey Pronin and Jason Meshberg joining me from Percona. We will talk about cloud-native database as service with Percona and MayaData, and simplifying database management on Kubernetes. And we assume our audience today has basic understanding of Kubernetes and data management on with the cloud native application. So on this webinar session, we will work with practitioners. We will not talk about many beginner concepts, but they can be found in our documentation link we will share at the end. Sergey, anything you'd like to add? Could you please introduce yourself?
Nothing to add, but just introduce myself. Yeah, I'm Sergey. I'm a manager of technical product managers at Percona, and I'm mostly focused on our Kubernetes operators and databases in the cloud. And I would be thrilled to share our knowledge and wisdom with you today.
Glad to have you. Thank you so much. And then this graph is from the most recent 2020 CNCF survey report. At the time we present today this session, 2021 survey was still in progress, and the report will be out probably before or during the Kubecon North America event. In summary, Kubernetes use in production has increased, and this report says up to 83%, up from 78 compared to a year before. And most importantly, more than half of the respondents use stateful application in containers in production these days. And organizations are testing new use cases or moving more workloads as they become more comfortable with containers. And again, in 2020, complexity, this graph shows that complexity joined with cultural changes with the development team shows up as the top challenge in using and deploying containers. As you can see, storage is on the 4th place by 29%. Sergey, can you tell us why people increasingly run databases on Kubernetes and stateful application on Kubernetes?
Yeah, sure. So we see it more like an evolution, right? It all started a long time ago with bare metal servers. There was a big, huge metal box where you were running your piece of software in the database. And later on, as IT systems were developing and the demand was growing for running the software, VMs appear, right? And firstly, VMs were considered not like something good to run your database at or even your application, because database administrators were hesitant. They were saying, hey, what about performance? If I run on a VM, my performance is going to degrade. I don't want it. And looking at today, right, we see that almost all databases in the cloud are running in VMs. Like RDS, it is a virtual machine with some virtualization behind it. And then containers appear, right? And the containers allow the users not to only just pack things more densely, but also it empowered the microservices architecture, right? So instead of having a huge monolith, huge multi-petabyte database, what was happening, the businesses were breaking down the applications and databases into smaller pieces. And once containers were going forward and running hundreds and thousands of containers started to become a problem, then Kubernetes appeared to orchestrate all these containers, right? And this evolution is ongoing, not only for stateless applications, but also for databases, right? And everything is moving to containers nowadays. Everything is turning into microservices, and for some containers becoming a strategy. And for Percona also, it is more like a customer user driven, because people started asking us, hey folks, how can we run our databases on Kubernetes? We're a Kubernetes shop, we're moving all our infrastructure there. And it's not only big companies, but also startups and even huge enterprises, right? If we talk about the databases on Kubernetes, usually it is a cluster, right? As Kubernetes is volatile and ephemeral, the nodes can come and go, containers are restarting and they're immutable. That takes a lot to run a database on Kubernetes because you need to configure this cluster and you also need to execute some management tasks. And it's not only the database that you're running, it's also some kind of a proxy, like for MySQL, can be HA proxy or proxy SQL. You need to configure a server, you need to configure the database itself to set up the replication, then to take backups, and so on. And at the same time, there are lots of options in Kubernetes world for storage layer. Your database can be running on local storage, on cloud storage like Amazon EBS or GCP compute storage, and some other cloud native solutions like Rook, for example, that you can run on your Kubernetes cluster. And the greatest complexity comes with day two operations. As I said, backups, scaling, upgrades, maintenance of the database. And this on Kubernetes is becoming a huge problem, especially for new users or for someone who just starts this journey on Kubernetes for databases, right? We're going to go to the next slide.
And having options sometimes can be a good and a bad thing as well, because as we see from the users, they are looking at the alternatives like managed database as a service. So they, developers and SREs, they just want database to work. And they don't want to think about storage concepts as we witness with our users. They don't want to think about how many replicas should I have with the storage. They just want the availability. They want their application to work.
Yeah, I agree. And as you said, what the user wants a database. The user doesn't want to configure the Kubernetes primitives like pods, stateful sets, or the database itself. What the user wants to get is a service. And that is where operators jump in nicely, because what operators do, they live in between the Kubernetes primitives and the application, or in our case, the database configuration. And instead of spinning up the stateful set, creating the Kubernetes servers, configuring secrets, config maps, everything on Kubernetes, and then going to configure the database, what the user does is just sending the manifest, YAML manifest to Kubernetes API saying, hey, Mr. Operator, please give me the database with this number of nodes, with this version, with this proxy. This is how I want to configure my backups. And that's it. Then the operator does the rest. It provisions the Kubernetes objects and resources and configures automatically the database. And what the user gets in the end state is just the endpoint, the root user and password that the user can use to connect to the database. And that's it. The user doesn't know anything about the database, how it is configured, what's going on behind the scenes. It doesn't matter. The operator does the rest, right? And it obviously, operator does the day two operations and management like backup, scaling, and so on, right? And if we talk about Percona distribution for MySQL operator, our goal is simple, right? We want to provide users with a way to deploy and manage enterprise-grade MySQL clusters on Kubernetes. And we do it with Percona XtraDB cluster, which is a synchronous replication based on Galera and MySQL. And we have numerous integrations, like out of the box, our operator not only gives you the cluster, MySQL cluster, but also provides you with HA proxy or proxy SQL. It is for your choice, right? HA proxy is for layer 4, proxy SQL is for more like deep dive into the queries. We also provide an integration with Percona monitoring management, which means you can deploy your operator, your database, and you get all the metrics, all the alerting out of the box just working. We also provide custom sidecars, so you can tweak the operator in any way you want, like do some benchmarking, do some third-party monitoring and so on. And obviously, and more, I believe it's the most important thing, is data operations, like backups, scaling, and everything that goes with the database and the pains of it. It works out of the box within the operator. And more to that, our operator is 100% open source. Anyone can use it. We are not going with open core model. Everything is open. All the features are can be accessed by the users with no fees.
Thank you, Sergey. This was really insightful. And what we witnessed in our community, probably 4 years ago when we were at Kubecon, well, some part of the users were still experimenting with Kubernetes. Is Kubernetes right platform for me? Should I containerize my workload? But the last 2 years has been well, we don't hear that question anymore. Kubernetes is now accepted, and people move their databases, stateful applications on Kubernetes. And questions last 2 years has been always, well, with the increasing use of operator or start of the operator, how do we do the second day operations? How do I keep my database updated, because now users have, instead of one monolithic large database, well, there are use cases for that too, but they now host hundreds of databases, and how do you upgrade when you need to? So one by one would be almost impossible. And now operators really changed our life. And as Sergey mentioned, well, every workload now comes with a different storage expectation and performance and availability requirements too, because distributed databases provide their multi-master replication, and using a legacy highly available storage would not only waste resources, disk resources, and but would also slow down performance. You can directly get from raw devices instead, because network adds overhead, and replication over synchronous replication over network would add another layer on top of what you already have with your database. And Percona XtraDB cluster PXE enables synchronous multi-master replication. Each node is regular Percona server for MySQL instances, and it implements proxy SQL in front of the cluster to assist with several functions, such as splitting read and writes traffic among nodes as needed. And these volumes need to be placed dynamically on a fast, reliable storage. So Percona XtraDB cluster can be provisioned with the OpenEBS volumes using different flavors of OpenEBS, such as local PV and CStore, Jiva, if there is additional high availability needed based on the configuration and application requirement. But in our session today, we will be installing PXE environment on OpenEBS Local PV hostpath. And before we get to the demo, I want to also talk about the lessons we have learned in the last 4.5 years, being working with the users, moving their stateful applications to Kubernetes. Kubernetes teams vary in sizes, but a large percentage of them are self-sufficient, small, mid-size teams in terms of number, and then per team control and granularity became really important to these teams, and being able to decouple storage from the infrastructure or cloud vendor is really important, so we can run the same environment, same manifest, same pipelines on any cloud, any hardware, even on-prem, and migrate if we need, if there is a change in any parameter, can be cost or any decision there. So we don't want our deployment to be affected or tied to infrastructure pieces. Kubernetes by design supports all these, we call it agility enablers, unless you are tightly coupled to an infrastructure piece, such as storage. And this is where OpenEBS project comes in, and open source, fully open source, easy to use, maintain, granular, as a big requirement, granular container attached storage solution. So it's a new term. It was coined after Kubernetes popularity increased. CAS and OpenEBS is a CNCF SAN project leading CAS solution in CNCF. Currently, also looking to take the steps to move into incubation, and it's as a storage solution. We should say that it's not a replacement to your storage. It's an additive to underlying systems or cloud volumes or JBODs or your existing appliance, because you don't overnight replace your storage system, legacy storage system. You want to convert and you want to take advantage of Kubernetes primitives, CSI primitives, and be able to granularly, dynamically provision volumes, so you reduce the complexity. How does OpenEBS Local PV hostpath works with Percona? So OpenEBS provides, as I said, multiple storage options, replicated and non-replicated options. So local PV option we will be using on our demo today is a dynamic host path provider. Kubernetes also has a local PV, but that requires manual provisioning, therefore may not be, or it's not suitable for dynamic scaling of your DB sometimes. And in this case, OpenEBS is in this deployment not directly in the data path. Therefore, there is no performance overhead at all. You get close to the raw device performance. There is only file system between your data and the device, especially with the latest NVMe SSDs. It's very important, increasingly important. So we will share the link to the repository at the end. What we have done here, we have created a Helm chart, and let me actually move to that screen. So what we have done, we have created a Helm chart, and then so what we have done here, we with the Helm chart, it installs Percona Kubernetes operator for Percona XtraDB cluster, and very simple, but actually reduces complexity a lot. It requires OpenEBS to exist, and if you go into the chart requirement, it's pretty much the same, and then it has dependency and to OpenEBS edit. And the other difference is if you go to values, you can see, so when it deploys the cluster, it uses the storage engine that OpenEBS creates, OpenEBS hostpath. All these parameters you can change the values file before you apply, but we'll just demonstrate what was documented in this repository to show you how it works. I'm gonna switch to my terminal screen. First install the repository, and before I do that, so I have a just before the webinar deployed, thanks to the new well, simplified tools available. So I use cups to deploy a 4-node cluster, and there is nothing on my cluster. So what you need to do, if you haven't done before, so need to add 2 repositories. Well, I already have it on my setup, but I'll run it. So it says it exists, and then you also need to deploy, add, oops, this is the same one. Add, let's say, Percona repository. So this also exists, and then you do Helm repo update to make sure you have the latest one. In my case, I have a bunch of others. So it's very simple. From the repository, you deploy, let me make the screen a bit bigger. So you deploy the chart, and you can also deploy this in a namespace if you prefer, but I'm just showing very basic. So what this will do, we'll get back to it, but what this will do, once it's done, we'll see we can get kubectl up, kubectl get paths, because I didn't pick a namespace, it just deployed everything to default. So it's doing its thing here. You can see get storage classes. Let me make it a bit smaller. With CS a bit more. So it created some storage classes. I wanna talk about this. 1 second, waiting for kubectl get pods. So to come up, it will come up shortly. And getting back to my slide here. So we have an optional step here. I shared a couple of default storage classes. If you prefer, and if you are running on different flavors of AWS, you get NVMe devices, faster devices. You can also create additional storage class for different type of databases to use that faster device. What you need to specify here, two things. One is name, of course, and where that device is mounted. So base path, where you want your host path to be stored, and the volume binding mode is, in this case, wait for the first customer. So after this, we will pass operator should be up and running. So it's very quick. So let's take a look. Hope my cluster is in good shape though. As I see, 1 out of 2 not running, and there might be a difficulty on my cluster, but this will not hold me to show you from showing you the next step. So what you do here from the Percona repository, there is another chart that deploys the database. So you can specify, create this in a different namespace, or just deploy it in the default for the sake of demo. But so I will just deploy this in a PXE namespace. You can also, again, set if you have a different storage class, you can define your storage class here. And let's take a look before we do that. Get CS very quickly. As you can see, so we have a host path, and let's describe the kubectl. Describe a storage class and get OpenEBS host path, which my PVs are using. Let's take a look how the default one looks like. So as you can see, it's using the default base path under var OpenEBS local, and to see, so you can see there is a PVC inbound, and then using that OpenEBS storage class. And so let's create this, and this will be it. This will create so, and you can follow these steps to root into your cluster, and this gets the root password from the secrets. and then using that password you can connect to the application. So, but that's not the point of our demo today. I'll go back to some additional details you may want to use. So same instructions, also step-by-step instructions are on our MayaData website. Under workloads, you can find Percona there. You can follow the step-by-step instructions to get your cluster up and running and use different flavors of OpenEBS. And so as again, a CNCF survey shows, complexity is an important problem blocker front of wider Kubernetes adoption or containerization, which OpenEBS enabled Percona together operator. You can use it to simplify. So everything you have seen in the demo and OpenEBS and Percona, like Sergey also mentioned, everything is open source, and there is a big community behind both projects. What we see from our users, and that was the purpose of building the joint operator. Dynamic provisioning really helps OpenEBS users to accelerate their deployment and provide autonomy to their developer and small two pizza teams, so they don't need to ask the storage admin to create a LAN and then mount it or add a device. So bar is really high in storage. Of course, cloud vendors have simplified the way we consume storage. Now the expectation is also the same. So you want everything to be provisioned very quickly, very fast. And so that's what we see when we hear from our community. So using this type of solution really accelerates their deployment of services into production. And here I share some resources. You can find the chart repositories from MayaData and Percona here, and our solution guide, also Percona CTO's blog about Kubernetes operators with OpenEBS local storage on Percona blog.